Hello, welcome back to yet another topic. We already finished random variables, as you know, and we start with the next called as theoretical. Starting with the pure confirm the term. Um, so what we are going to start topic binomial confirm uh, last binomial. So let's begin with the introduction of actual theoretical distributions. What theoretical? I mean, we have already studied some kind of thing, right? Like what's random variables and what type of random variables you have. So what does theoretical distribution does is kind of enables us to fit a mathematical function or a mathematical model rather to the given data, right? Depending on the type of data. If the type of data is discrete, then it has certain kind of distribution. If the type of data is continuous, then there's certain kind of distribution, right? So we have already studied all the necessary tools, right, to be actually starting with theoretical distribution, right? For example, we have already studied like some of variables, probability functions, right? Then PDF, that's probability distribution function related to continuous probability. Then probability mass function we have studied. Then expectations, right? Mean, variance in terms of expectations, and so on, right? So let's study the theoretical distributions in detail, right? So what we are going to study is these are discrete, right? These two are discrete probability distribution, right? Distributions, right? And this is a continuous probability distribution, right? So we're going to study two discrete probability distribution and one. Let's begin the idea of binomial distribution. Okay, so what is binomial distribution? Binomial distribution is mathematics. It was published after his death, anyway. Right? Distribution, Bernoulli, binomial, uh, binomial distribution is sometimes called as Bernoulli uh, and two, Li, Bernoulli distribution, right? Bernoulli distribution. Uh, after the Swiss mathematician James Bernoulli, James Bernoulli discovered it, discovered covered it in 1700, right? When do we use this system? Uh, when do we use animation? Right? The distribution, yeah, question when use this kind of distribution. This tool can be used under following conditions. Under following conditions. Right? What are the conditions? Need. Okay. Right? First one, when is performed, you know, in a fixed number of times, repeatedly, in a finite and fixed number of times. Okay. Right? So number of trials are say, implemented random experiment, random experiment perform 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 um, repeatedly, uh, and fixed number of times. Okay. In other words, in other words, in other words, number of trials, the number of trials, or the number of times you repeat it, you know, is uh, six and five. Um, and the, that's the first thing. Second, similar trial, outcome of the random experiment may be classified to mutually dis mutually uh, namely success, right? That's occurrence, right, of the event. Let me see, occurrence, right, and failure, right, non-occurrence of the event, rather, you can write that, right? Third one is, right, so third one, all trials are independent. All trials are independent. That is the result. The result of any trial, right, is not affected in any way by the previous previous trial, and does not affect not affect the result. Does not affect the result of. Okay. The fourth one is is not influenced by the previous trial, will have nothing to do with the future trial. Okay. Fourth one, the probability of any trial is same, right? So it's named as P, right? And is constant. Every time you repeat a trial, P is constant. Okay. And the outcome, sorry, each trial, and each trial Q is equal to 1 minus P minus success. Uh, it is then termed as the probability of failure, as the probability of failure, isn't it? Right? And also is constant. And also is constant for each trial. So, what would we take an example of binomial distribution example? Let's take example, right? For example, uh, a unbiased point, and I right? This fixed, right? Fixed and finite. The n is fixed and finite. Confirm, right? Then, then what are the possible outcomes? Then uh, of any time is one of the events. Right? And one of the events head and tail, right? So this is like the situation when you can fit in the binomial. You know that there are only two kind of the success one is and these are not affected. And since result of any toss is not affected, not affected or affect result of other result of so another situation is toss or throwing a die. You know, the probability of getting success will be getting a number, and probability of getting a failure is not getting that number. So again, you see, the situation can uh, uh, more. So let's write down more precisely, more precisely. right? We can expect, right, uh, the binomial distribution under the binomial distribution under 1, number of trials are finite, right? Second, each trial results in each trial results in two mutually exclusive and exhaustive outcomes. Third, trials are independent. Trials are independent. And the fourth one is P is equal to probability of success, right, is constant for each trial, and Q equal to 1 minus P is probability of failure and is also constant, right? So these are the probable conditions uh, to be satisfied if you are supposed to use a binomial distribution, right? Uh, so let's write that, a remark, a note. Okay, the trials satisfying above 4 conditions are called as Bernoulli trials. Bernoulli trials, right? So, when it's a probability distribution, it's obvious to talk about what is the probability function. Okay, so let's look at next uh, probability function of binomial distribution of binomial distribution. Okay, so what's going to be the probability distribution of the binomial probability function of the binomial distribution. Okay, so let's write down, if x denotes the number of successes in n trials, right, satisfying the above four conditions, namely its number of trials are finite, they are independent, and probabilities of getting success is constant, right? And those two outcomes, there are two outcomes, and both are mutually exhaustive and exclusive, right? So I hope that idea is clear. Mutually exclusive and exhaustive, right? About 4 conditions, right? Then x is a random variable which can take the values, right, 0, 1, 2, so on up till n, right? We can get one number of failures, no success, right? That's failure, right? So one number of success, two number of success, so on up till n number of successes can be got, right? Then the probability of getting R number of successes, is given by PR, which is Px at R. It's given by NCR into P raised to R into Q raised to N minus R, right? So this is a very important formula for us because that's the probability mass function, right, for the binomial distribution. Okay, let me name this as some star, right, where N and P are parameters, are called parameters of the binomial distribution, because the binomial distribution is decided by these two parameters, right? Also note that it's very important, always we are referring this. Also note that the total probability in any case is 1. The total probability is 1. That is P of 0 plus P of 1 plus P of 2 plus so on up till P of n is 1, right? That's next thing we need to remember. Okay, right. So so what we are doing is we are taking some notes. Okay, so okay, so this is 1. Let me name this as 1. Okay, second, right, P at x equal to R, right, this one is called the probability mass function. It's called as a probability mass function, right? As underline that. Of the binomial distribution called a probability mass function of the binomial distribution with parameters and p, right? The random variable x, right, following the law in star, right, is called as binomial variate with parameters n and p. Okay, so then let's look at some formula as well. I'm not gonna derive that, but one can look at that, you know, what exactly you get, right? We are not gonna derive that. So what we have is okay, one can think of deriving. It's not that difficult. Mean of binomial distribution. It's not hard to actually think about this, right? We have mean of a probability distribution, discrete probability distribution, right? Let's name this as mu, is given by expectation, right? By the previous chapter. And expectation is given by x into probability of x, right? X varies over 1 to some n number of probabilities corresponding to the random variable. So here this would be summation x going 0 to n, right? X going from 0 to n. This would be x into probability of x. This is nothing but n cx, right? P raised to x into q raised to n minus x, right? This would be equal to we can just like this is x equal to 1 to n
right? X into n, sorry, let's write this n factorial, this is ncx, right? N factorial x factorial into n minus x factorial, right? This is p raised to x, q raised to n minus x. So what I'm doing is I'm taking p and x out, sorry, p and n out. So what I'll get is, first of all, I can cancel this x, right? So this would be p into n, or np summation n going from 1 to infinity. In this case, this would be 1 to infinity, right? 1 to infinity, 1 to n, sorry, right? This is x is gone. This is n minus 1 factorial over x minus 1 factorial into n minus x factorial, right? N minus x factorial. This is p raised to x minus 1, q raised to n minus x, right? This is equal to np. This, right, is equal to summation n going from 1 to n, right? This is n minus 1 c x minus 1 p raised to x minus 1 q raised to n minus x, right? So if I look at this, this is now equal to np. If I look at this one, this is like, if I keep on putting x, by the way, I made a mistake somewhere. Yeah, this is x, not n. This is x, right? So if I keep on putting x equal to 1, 2, and so on, this will be n minus 1 c 0, right? P raised to 0 q raised to n plus n minus 1 c 1 p raised to 1 q raised to n minus 1 plus so on up till n minus 1 c n, right? This would be q raised to uh, q raised to n, isn't it? If I'm not wrong, right? But this is like np. If I'm correctly writing this. Uh, Sorry, n minus 1, isn't it? I made a mistake. Yeah. If I put n here, this will be n minus 1. So that's 1. So this is like the binomial formula, right? P plus q raised to n. Isn't it? N minus 1 rather. But p plus q is 1. We know that p plus q is 1. So this is just n times, right, p, n into 1, which is, gives you np, right? So mean, right, therefore that's a derivation one can think of. Therefore mean, right, of binomial distribution, which we name as mu, is just n times p, right? Variance I'm not deriving, right, but one can think of, if somebody is interested, variance of binomial distribution, right? With respect to expectations, we know that variance of x is nothing but e power x squared minus e power x the whole square, right? So one can think of doing this, right? The same argument, if somebody is interested, right? Or somebody, if not interested, can remember this formula. So v of x, we name this as variance, right? This is n p into q, right? That's the variance for us. And the standard deviation is square root of variance, right? Standard deviation, right, is equal to square root of variance is square root of npq, right? So one cannot, one need not draw, I mean, kind of derive. If somebody is really interested, you can go ahead and look at what is v of x and kind of derive this formula what we have just derived, right? But I would leave it to individual whether they are interested or not, right? Let's look at the problems anyway. So let's look at the following example. So let's look at the problem. Uh, an unbiased coin, sorry, it's tossed 10 times, right? And we need to find the probability that I get exactly 6 heads, at least 6 heads, no heads, and at least 1 head. Well, we have done this kind of problems. Only thing is now we have a probability distribution in binomial distribution, but nothing is changing the fact, right? So this is an simple problem. All you need to know is what is n here. N is 10, so you're tossing the coin 10. Now you are tossing a coin. What's probability of success? Probability of success is half. Probability of failure is 1 minus half. That's also half, right? So what's the answer of the first question, right? Probability of getting exactly 6 8. So my r here becomes exactly, or x equal to whatever it is exactly becomes 6. So let me use x in place of r. It's exactly 6, right? So if p is x equal to 6, then what's the formula? If we go back and check out what's the formula, right? It's ncr. That means if I replace r by x, this is ncx, right? So p of x equal to 6 would be ncx p raised to x q raised to n minus x, right? My n is 10, so this is 10 cx. X is nothing but 6 from here, right? Into p is half raised to 6, right? Into q is also half, so this is half raised to 10 minus 6, that's 4. So this comes out to be 10 factorial over 6 factorial into 4 factorial into, this would be something like 1 upon 2 raised to 6 into 2 raised to 4. But if I use the indices, this is 2 raised to 10. I hope the index is clear. This is 1 upon 1 raised to 6 upon 2 raised to 6 is 2 raised to 6 multiplied by 2 raised to 4, and then you add their powers because the base is same. You get 2 raised to 1 by 10. Uh, then if I use little bit calculation here, this is 10 into 9 into 8 into 7 over 4 factorial. This 4 into 3 into 2 into 1 into 1 upon 2 raised to 10. And if you use your calculator and kind of calculate these, what you kind of get is something like 0.025, 0.2025, sorry, right? Just check out my answer. Just again, let me kind of take the liberty that I am very bad in calculations. Okay, gotta check my calculations. Okay, the second one, probability of x greater than or equal to 6, right? That would be probability of x greater than or equal to 6 would be either you subtract probability of 0 1 2 3 4 5, right, from 1, or you can calculate. This is probability of x equal to 6 plus probability of x equal to 7, probability of x equal to 8 plus probability of x equal to 9 plus probability of x equal to 10, right? This would be what, 10 c1, sorry, 10 c6, right? um, half raised to 6 into half raised to 4, right, plus 10 c7 half raised to 7 into half raised to 3, 10 minus 7, that is 3, plus 10 c8 half raised to 8 into half raised to 2, plus 10 c9 half raised to 9 into half, plus 10 c10 half raised to 0, half raised to 10 into half raised to 0, right? Then if I do little bit of calculation, what I can do is, if I just calculate this, what is 10 raised to 6, you can use your calculator if you have scientific calculator. Otherwise, you have to do little bit of calculation. But what I can do is I can take this powers. I can take these powers out. So 1 over 2 raised to n is common, right? This will be 10, this will be 10, this will be 7 plus 3, this will be 6 plus 4, all 10. So 2 raised to 10 comes out, right? And if I calculate these things, right? So what I get is 2 raised to 210 plus 120. You can calculate this, plus 45 plus 10 plus 1, right? This is exactly equal to 386 over, this is 1024, right? This can be equal, this is equal to 0.377, right? Just a calculation involved here, right? I hope you can calculate this 10c. You just have to calculate what is 10c8, 10c9, because these are all 2 raised to 10. And then it's not so difficult using calculator. What is 2 raised to 10? You have to multiply 2 10 times, right? We get 1024. Then probability of getting no hits, that's probability of failure, right? Percentage x equal to 0, that would be n c x, right? P raised to x q raised to n minus x. This is 10 c0 p raised to 0 q raised to 10, right? this is 10C0 is 1. Remember, NC0 is 1, NCN is 1, right? You got to remember these parts. Okay, so this is 1, p raised to 0 is 1, and this is half raised to 10, right? This is 1 upon 102, what? 102? We have got something 1024. 1024. You can see that this is 1 upon 1024, and if you use a calculator, this comes out to be something in 0.00099 98 rather. You can check out that 980. Okay, and probability of getting at least one head is this is probability of failure, right? Probability of getting no head, right? That means probability of getting at least one head. So x greater than or equal to 1 is you take total probability, you subtract it that probability that I'm not getting any head. This is like probability of getting no head. So probability of getting at least one head would be probability of 1 minus total probability, that is minus probability of getting no head, right? Simple. This is 1 minus 0.000980, and this comes out to be, if you subtract, this comes out to be 0.99902. Okay, it's a very simple problem to begin with. Okay, let's look at the next problem quickly. So if I look at this problem, it's same as what we have just done, right? So let's look at this. What's a n here? First thing, we need the parameters, right? So n is 8. It's thrown 8 times, and it's a die, right? So probability of getting a 6, right, is 1 by 6. That's a probability of success. And probability of failure is 1 minus probability of success. That is 1 minus 1 by 6 comes out to be 5 by 6, right? So that's probability of failure, right? Therefore, let's calculate one by one, right? Probability of exactly 5 sixes, that probability of x is equal to 6. This would be ncx p raised to x, right? Just write down that p raised to x q raised to n minus x. So this is n is 8, c x equal to 6, right? P is 1 by 6 raised to 6 into 5 by 6 raised to n minus, that's 8 minus 6, that's 2, right? If I'm not wrong, exactly 5, right? So exactly 5, sorry, a mistake. This is 5, this is 3, sorry, 5 sixes, right? This is 5, this is 3, right? This is also 5, I gotta make a mistake. This is 5. All right, all right. Okay. So so what is this? This would be equal to 8 factorial upon 5 factorial into 3 factorial. This comes out to be, this is multiplied by 5 cube. That's 125 over, this is 6 power 5 and 3, 6 power 8, right? So this is 8 into 7 into 6 upon 5 factorial get cancelled. This is 3 into 2. So this and this gets cancelled. This is 125 over 6 raised to 8. 6, you multiply 8 times, you will get some number. That's a big number. So this is 7,000, right? You get this to be 7,000. 125 into this, 7,000. Just check out calculation. My calculations may be wrong. So 1679616, right? 6 raised to 8, and this comes out to be something like 0.000417. Again, I'll let you know that my calculations pretty weak. That is what you must get, right? Then second one is probability of at least 5 sixes. Again, that's very like, probability of the second one, probability of x greater than or equal to 5 is probability of x equal to 5 plus probability of 6 plus probability of 7 plus probability of 8. So what is this? This is 8c5 1 by 6 raised to 5 into 5 by 6 cube plus 8c6 1 by 6 raised to 6 into 5 raised to 2, 6 raised to 2 plus 8c7 1, this is 7, 1 by 6 raised to 7, 5 by 6 plus 8c8 This is 1 by 6 raised to 8 into 5 by 6 raised to 0. That's 1. So what I can do is I can directly take 1 over 6 raised to 8 out, right? And if I have it in the bracket, this will be 8c5 into 5 cube, that is 125, plus 8 6 8c6 into 5 square, that is 25, plus 8c7 into 5 plus 8c8, right? This is something like, this comes out to be, just multiply this and check out, this is 7741 upon the same number which we got just now. That's 1679616, right? 1679616. This comes out to be 0.000461. Okay, right. Then third one is pretty easy. Probability of getting no sixes is 10c0 1 by 6 raised to 0 into 5 by 6 raised to 8, isn't it? This comes out to be 0.2. Just this is 0. This is equal to, exactly 5 by 6 raised to 8. You can calculate what you get there. You must get something like 0.2325. And the fourth one is probability of getting at least one head is 1 minus probability of getting no head. This is 1 minus 0.2325. That comes out to be 0.77. Right, right. You can check that out. What you get is this much. Calculations, I am not too sure. My calculation generally can falter, right? So I just warn you again that just check my calculations, for your betterment. I can leave an example for you. These are some simple example. I'll give you more. You can try this for your, for the time being. The probability that a student, that a student, the probability that a student does know to dance is 2 by 3. If 5 students are selected at random, selected at random, are selected at random from a class, from a class, right? Find the probability that, find the probability that one, nobody is dancer, nobody is a dancer, nobody is a dancer, right? Second one is exactly two are dancer, exactly two are dancers, and the third one is all are dancers, all are dancers. Okay, so this I leave it to you. Please try this, right? Look at more problems. So let's look at this example here. Uh, So let's look at this problem here. It's given that for a binomial distribution, I have n is equal to 6 and p is equal to 1 by 3. 1 by 3. So what is given to me is the parameters for a binomial distribution are given, right? And what is asked is mean, variance, and standard deviation. Now that's all we need to do. So this is n equal to 6 is given, p equal to 1/3 is also given, q is 1 minus p, which is 1 minus 1/3, which is 2/3. As simple as that. We got to find mean, right? Mean is nothing but n times p. N is 6, p is 1 3, so mean is 2, right? What about variance? Variance is nothing but n times p times q. N is 6, p is 1/3, q is 2/3, so this is like 3 into, this will be 3 into, this will be 2, right? So mad, so bad. This is 6, right? So 3 cancels, this is 2, so this is 2 into 2, 4 by 3, and therefore standard deviation, right, is equal to square root of variance. which is nothing but square root of 4 3, which is square root of 4 over square root of 3. This is 2 by square root of 3, and that comes out to be something like you can find out this 1.15. Check out again. I'll leave that to you. Calculations, always play safe, right? Give it to you and check out if it's correct. I think it should be correct. Okay. Like example. Okay. Uh, given that given that mean and variance of a binomial distribution are 4 and 4 over 3 respectively, right? We need to find probability that at least find probability that probability of at least 4 successes, at least 4 successes, right? Solution. Um, well, we are given, we are not given n, we are given mean, and we have been given variance, right? So if you want to find probability of 4 success, I need to find what is n, what is p, what is q. Let's do that. So mean, we know that is equal to n times p. This implies that 4 is equal to np. Variance, on the other hand, is npq, but np is given by 4, so 4q is equal to variance, that is 4 by 3. So this 4 gets cancelled, implying that q is 1/3, right? If q is 1/3, p would be nothing but 1 minus q, because we know that p plus q is 1. Remember that total probability is 1, right? Probability of success plus probability of failure has to be 1, isn't it? So this is 1 minus 1/3, that's 2/3. Great, nice. So we got p, we got q, and mean we need n, right? Mean is nothing but np. Mean is 2, and p is 2/3, so this gets cancelled. Mean is 4, sorry. So this is 4, my mistake. So this gets cancelled, you're left with 2, 3 to the 6, and n is equal to 6, right? So therefore, probability of at least 4 successes, that is x is greater than or equal to 4, right? This is equal to probability of x equal to 4 plus probability of x equal to 5 plus probability of x equal to 6, right? This is like n c4, right? Sorry, 64, right? 2 by 3 raised to 4 into 1 by 3 raised to 6 minus 4, that is 2, plus n, sorry, again mistake, it's n is 6, right? This is 6 c 5, right? 2 by 3 raised to 5 into 1 over 3 plus 6c6, 2 by 3 raised to 6 into 1 by 3 raised to 0, right? So what this comes out to be, well, you can check this out. This comes out to be, I mean, this entire thing comes out to be 0.32, right? This comes out to be 0.26 plus, and that comes out to be 0.087. Please calculate and check out. You can do that. I hope this is 0.66, right? That's the probability of x greater than or equal to 6, right? Well, that's about binomial distribution. Next time when we come back, we would do how do we fit in a binomial distribution, right? How does probability distribution works, right? How to fit binomial distribution to given data, right? um, well, that's it. Thank you. Thanks a lot for watching. See you next time.